Hi, this is David Carasso. I'm going to be walking you through an app that I wrote called Timewrap. It's a simple app. It adds one search command called Timewrap, and we'll walk through it and see how you too can build an app. The app is here at apps.splunk.com, and briefly what it does is it allows you to wrap time ranges around each other so that you can compare one week to another or one day to another. So here, for example, I did a search. It doesn't matter what the particular first part of the search is, but I did a standard time chart search. And then I said time wrap after that. And what time wrap does, wrap the times around each other so that you're comparing the previous week to the previous week to the previous week. And they're all sort of put together into the current week. So you can see there's a series here called last week, 1 week before, 2 weeks before, and so on. There are different arguments for time wrap, some interesting things you can do. But the bottom line is it's an app that adds a search command that's very useful because it makes it easy to search to compare different time regions. So now we're going to walk you through how I built the app. Okay, now we're in an editor, and I'm going to show you how the Timewrap search command and app is built. So where are we? We're in our Splunk directory, etc apps. These are where all our apps live. I've got a bunch. We're going to go into Timewrap, and we're going to go see what's there. Because this is a small app, there's only a few directories needed. There's bin, default, metadata, and static. We'll go through each one and explain what the files are doing line by line. We'll start off by looking at default. And in default, you have your configuration files. In here, we have an app.conf, commands.conf, and searchbnf.conf. So app.conf is a basic file that basically will show you things about your app. So the UI, I actually make this is kind of interesting, I make the Timewrap app not visible as an app itself. This is pretty unusual. So generally you're going to want to make your app be visible. But in this case, what it is the app adds a search command, so there's no reason that it should have its own app icon sitting on the user's homepage within Splunk, on the launcher. So I say invisible. The name of the app is called Timewrap. I say who made it, what it does. I have a version number. If you're going to install your app, if you're going to upload it to apps.splunk.com, you need to have a version number. And then whenever you make a new version, you obviously increment that. There's an install stanza and a package stanza. And you're just giving it a unique ID for your app that no one else will have. I can't remember what build equals 1 is about, but there you go. Okay, the next one is commands.conf. So this is a file that's used to describe how a search command behaves. It tells the Splunk search language certain things about it. So these are specifically for Python external search commands. So that's how the Timewrap command is an external Python search command. For example, I'm saying that the actual file that this command lives in is called timewrap.python. I'm saying that it supports getInfo equals true. I'll explain what that is once we get into the source code. That it also supports raw arguments. That it is streaming is false. And what that means is in Splunk, a search command can either be streaming, which means that as data comes in and is passed to the app takes a chunk of that, operates on a chunk of that, and spits it back out. Timewrap is generally the last search command of your search and operates over a very small amount of data, and it actually needs to see all of the data before it does anything, so it's not streaming. So it operates on all the data in one big chunk. And because it's usually followed by time chart, there's actually very little data, so it's not a concern. Enable header is true. That means I'll explain later in terms of how we spit out data for the Python search command. Retains events is false. So the data coming in to this search command is not the same data that's going out. And regardless, timechart doesn't retain events either. This would be true if you were adding a search command that took standard Splunk events, with a raw and a time, and were to add a new column or change a field value. But certain search commands, like timechart or timewrap, will fundamentally change the data so that it's more of a summary view, and no longer is there a one-to-one correspondence between the event data that originally was indexed and what is output by the search command. Changes column order is true, so this search command can change the order of the columns and the columns themselves. Overrides time order, true. So these basically are saying these are optimizations. So if you say they're false, then Splunk won't bother sorting the results of this search command. Output header is true. That means that we output the field names. Generating is false. A generating search command is one that generates its own data. And the majority of search commands in Splunk rely on data coming in from the search operator. But a generating command like metadata or crawl or event counts will generate their own data. They're responsible for going and getting the data. But that's not what this app does. This app merely takes data from timechart and convolutes it. Run in preview, true. So this probably isn't relevant for this particular command, but if this is true, Splunk will actively show a preview of the results being spit out by this search command, so that the user isn't left waiting for any results until the very end. But because this search command actually is not streaming, this is kind of irrelevant. Max inputs is 10,000, and this is sort of a sanity check for Python. If you're going to pass a Python search command a lot of data, you're going to have to think twice about doing that, because for performance reasons. And in this case, because timechart precedes timewrap, there's usually very little data. And then finally generates time order, which just says your search command is responsible for generating the time order. If you're in doubt as to what any of these mean, you can always go to system readme commands conf spec, and all these things are described in greater detail. Okay, so that's commands.conf, and next is search BNF. What this configuration file does is it specifies hints and help to the user. So let's go back to the app itself. So when I type in the timewrap command, you see this help right here. It gives me a description of what the timewrap command is, some examples. I can click more and get some details about the syntax and everything else. Where does this come from? This comes from searchbnf.conf. So let's open this file, look at it. So there's a stanza for the name of the search command, followed by dash command. The syntax attribute has equals, so the name of the command, and then the arguments. So here we're saying there's an integer, and the field name of that integer is called scalar. So we can see right here in scalar, hours, days, weeks, months, quarters, and then another argument called series, whether it's relative, short, exact. So these are just describing the syntax. There's a short description, which just is used if I say less. This is the short description. and this is the long description. So short description is right here, long description is here. It's all one line, this is one value. If you wanted to wrap it, you could, the last character is a backslash, then you can keep on going. So I could do that and so on. But I just happen to put it all on one line. It's the more common thing people do. The next are a series of comments and examples. So let's go back here. What the search assistant is doing is it's generating, let me do less, there we go. So these examples, there's a comment, an example, a comment, an example, comment, example, and they're right over here by comment 1, example 1, comment 2, example 2, and so on. So you're just giving the user a hint as to how to use the search command, and covering the basic topics. Usage, if you want this thing to be public, you generally just say public. What version of Splunk it appeared in, this really isn't used. Who made it, this really isn't used. Tags, so this is sort of interesting. So time, week, month, day, warp, wrap. So these are aliases to the search command. So if I were to type in, let's go back here. If I forgot the name of the command, but I said something to do with warp, the search assistant would suggest, hey, do you mean Timewrap? And it would change it. So these are convenient aliases. So if you have a search command, you might want to think about some aliases for it. Time chart also, let's see, time. If I were doing a time chart, am I showing related? Related down here, there should be, but I guess there's not. Timewrap. Anyway, let's go back. Okay, so this is the search BNF file. The best way to learn what exactly this file needs is to look at the standard one that comes in the search app. Well, there's a couple, but let's look at this one. Not there. It's in System, Default, Search BNF. So this is the main one for all the different search commands that are in Splunk. Once again, that address is etc system default search BNF. So this is the source for the search assistant, and it goes into detail about all sorts of things that, in fact, the documentation even skips over. So if you go to our website and look at the documentation, sometimes it won't describe everything in detail as well as this will. So extract options, and you have all the different things. So there's a lot of detail here, but learning by example, that's really the best way to go. So those are all the files in the default directory. Once again, apps.conf, where we just basically said gave this app a name and who made it and a version. Those are the key things. We described what this Python search command, how it behaves, and then finally we gave it a nice piece of text for the search assistant. Okay, so let's go back up. So we've looked at default. Let me show you metadata, and then we'll get to the meat of the programming. In the metadata directory, I just have one file called default.meta. And this basically talks about the permissions of the various objects in Splunk. And so for this app, I want everybody to be able to use the search command, and everybody to be able to see the search assistant help. So when I want everybody to be able to see this Timewrap stuff, no matter what app you're in. I happen to be in the search app, but if I was in any other app, it wouldn't matter. I would want this functionality to be available to them. So basically, I'm saying all the search commands that come from the Timewrap app, they should be readable, and only admin can write them. And I want to export them to system so everybody can see them. And for the search BNF, for the search assistant stuff, same thing. And that's all there is in the metadata directory. So now we've gone through that, we've gone through metadata, and the final things we have are static and bin. So let's go through static because that's easy. This is all I have here is just icons. These are just the icons that you would see for the app. So it's basically this icon here. This is an unusual app in the sense that it's not visible. So the icon isn't visible in the Splunk product, but that icon is used on apps.splunk.com. So you should at least always have one. Your app may not even be accepted if it doesn't. And there are various resolutions that these should be in. You can find more about that exact resolution and information by going and clicking on Develop and then Packaging a Splunk app. And here they will tell you all about the different images and stuff. And there will be links here describing it. Okay. We've gone through default, metadata, and static. Static just had the app icons. Okay, so now let's go to the meat of the app, which is called Timewrap. So in the bin directory, the binary directory, we have our one Python search command, Timewrap. Let's open this up. I'm just going to walk through this, not in 100% order, but I will try to cover everything. Okay. So I'm importing a bunch of libraries: regular expression, system, time, CSV, traceback, and then I'm using splunk.intersplunk.si, and I'm relabeling it as SI. So intersplunk is a collection of Python utilities that are useful for getting data out of Splunk and sending it back out. The way a Python search command works is Splunk will call you with a CSV file as standard input, and you will output results as a CSV standard output. There's a little bit of hand waving there, but in order to make that a little easier, there's a bunch of functions in intersplunk. I drop to the bottom of the file and we'll look at the main. So we say, if this program is being called, in other words, this file is not being included. So I'm not sure how much I should go into the specifics of the search command because it's not so relevant to learning how to write your own, but I'll walk through it. So the timewrap command has an argument called series equals relative, short, and exact, which basically will output different names of columns. So the default is last week, 1 week, and so on. If I said series equals short, it'll just give them names like S0, S1, S2, and so on. And there are reasons why that is actually really helpful. The last one is exact. So let's just do this just for completeness, show you what it does. And it just shows you the exact day. So you know exactly, it's not like 1 week ago, 2 weeks ago, you know the exact name of the week. It's the week of May 7th. Okay, so there's an argument called series. So I just say series mode equals relative, so you know that's just going to be the default series. I say get info, and SI, remember that's up here at the top, that's inner Splunk. I'm calling it .si. And I'm getting I'm asking, does this search command have get info, and what are the arguments passed to the search command? I get the length of the arguments. If there isn't 2 or 3 arguments passed to the search command, I go and print out a usage message. So right here, I say generate error results, and I just give a nice little warning. So let's see that in action. If I do that and I run, you get an error, right? So error in Timewrap command. So right here, same thing. Time unit argument is required. Time unit argument is required. So I just have a usage message. So then, assuming there's 3 arguments, I say, okay, let's get the second, which is really it's argv is 0 base. So the 0th one is the name of the file, and the first, and so on. So then I'm basically calling regex to pull out the value of short, exact, and relative. And if I get a match, if I don't get a match, then I also print the usage. So that's just saying series equals something, and I get another error. So this is just checking that the series name is equal to short, exact, or relative. And if we reach this point, then great. We just go and grab the value of group 1. So in regex is a parentheses not followed by a question mark means to extract out the value. So I want to extract out the value of whatever matches inside these parentheses, and inside these, and that's called group 1. And if I had another set of parentheses over here to grab something else, that would be group 2, and so on. Next, okay, so the way this search command works is it actually gets called 2 different ways. The first is by Splunk calling it and asking it about itself. So in order for Splunk to call it, you can either specify how your search command works in commands.conf, but in addition, you can also say, let's go back there, etc apps, oops, default commands. So we said get info, supports get info equals true. So because this app supports get info equals true, Splunk will call you with get info true before it actually runs the search. And you're responsible for outputting info. So I'm saying this is not a streaming command, this is not a generating command, this doesn't retrieve events, or doesn't return events, sorry. It has a required operator. So here's another interesting thing. So this search command is actually not a trivial one, and I don't want to pass over it, but these may not be typical. If your search command probably will not need this, but if it does, or if you will in the future, you'll find this interesting. So when you call Timewrap, actually the Timewrap command needs another command to run ahead of it, but you don't want to have the user to type in that command. So there's a command called add info, and it adds common fields. So let's go look. Let's see what it adds. So it added a field called info max time, info min time, info search time, and so on. These are fields that will tell search commands down the line when is the earliest time this search ran and when is the latest time this search ran. So the reason that's useful is in order to calculate these time ranges for the Timewrap command, I need to know over what range are we talking about. In other words, the UI says last 30 days, but how do I know? So what I do is I say, you know what? This search command requires an operator before it. And what is that operator? The pre-operator is called add info. And then finally, does this search command return things in time order? The answer is false. It seems to actually return them in the opposite time order. I don't know why. There you are. And then finally, you go and get the results. So basically, the data at this point, this data is being passed in, and it's being passed into results. there's a dummy setting, there's a dummy results and a settings thing here that we don't really need. This get organized results returns 3 values. The first one's the only one that's important. So these other two are sort of legacy. So the bottom line is we got our arguments, we got our search results that are passed into this search command, and now we're going to actually do something. So now we're going to call a function I very creatively called run, and I'm basically going to pass in the first argument, the name, the series mode, short, exact, and relative, and then what the search results are. So let's go to the run function, and so the first argument, if you noticed, was let's go back. The first argument was 1 week. It's right here that I called it with. So just another argument passing, another argument parsing piece of code. I think if I were to organize this better, this code shouldn't be here. It should really be back down in the main with the other argument parsing, or even better, I'd put them all together in one function called parse arguments. But I have something called parse span, and what this does is it says, okay, take the first argument, which is this 1W, do a regex search looking for 0 or more digits followed by a letter, seconds, hours, days, weeks, months, quarters for you financial people, and let's pass that 1 week piece of text in. If we didn't get a match, then we say that the time unit is required, and these are the valid values. So, for example, if I were to enter Z here, right, you would get an error right here. So we're checking that it's a valid syntax according to this. If it's not, we issue an error and we exit. Supposing it is valid, let's go and get the scalar and the units. And we're calling the regex function match.groups, or actually we're calling the group method on the match results. So scalar is equal to this first, remember I said parentheses are extracted from regexes, so this first parentheses is the first value, the second parentheses is the second value. So the scalar, the 1 week, the 1 is the scalar and the units is the W. If there is no scalar, then remember I said it could be, this star in regex means 0 or 1, so if there was no digit there, for example, if we just said W, then the scalar would be empty, and we'll set the scalar to 1. So 1, W, or W are the same thing. Next, we get the scalar, and this is, sorry, that's the scalar. Then we just convert it to an int, because right at this moment, it was a string. Then we look at the units, and if the units is seconds, great, we're done. If it's hours, let's just take the number of seconds and multiply it by the number of seconds in a minute and number of seconds in an hour. If it's a day, if it's a week, and so on, we just do the math. Two interesting things. Month and quarter are kind of bogus in the sense that months have different number of days, and to calculate it is really not only hard, but it's misleading. I kind of want to take these arguments out, because what does it mean to compare 1 month to the previous month? It's, you know, if 1 month contains 28 days, one contains 31 days, I don't know what days you're really comparing to what. It doesn't quite make sense. It would be much better to unambiguously say you're comparing the current 4 weeks to the, you know, the current week to the last 4 weeks of the current, or 4 weeks to the previous 4 weeks, and so on. So you could do that by just saying that, and you're saying that's almost like 1 month, but it's just much more exact. You're saying comparing the last 4 weeks to the previous 4 weeks. So all this did is we returned the number of seconds, the scalar, and the units. So now that we've got that, we're continuing on with returning these results. Max time is undefined, -1. That's what I mean by that. Now what we're going to do is we're going to go through each results so this function was passed in the results of the time chart command. The time chart command and add info, actually, which was behind the scenes called. So it was passed in these results. So we're going to go through results. We're going to go through every single line, every single event, this whole line, that whole line, and so on. And we're going to look at them. And so if max time is 0, which is true because we said it's -1, is less than 0, then we try to get the max time. So all this is saying is, let's try to get the info max time. We're going to get that. So result is a row. I should call it row if you want. We're going to pull out a value called info max time. Info max time is this column right here. We're going to pull that value out, and we're going to call that the max time. So you see they're all the same value. That add info command just put the max time on every single event. So we only need to do it once. So we're basically saying, if we haven't set it yet, let's set it. And if we don't have it for some reason, this should never happen, but let's say somehow there was no max time column here, then let's just use the current time. It's like a fallback. Let's use the current time right now. So this is the number of seconds since 1970. Finally, let's take the max time and subtract 1. So the way the time ranges work is they're not inclusive to the very last second of that time region. A little detail about this particular search command. If _time is not on an event, then what the hell are we doing being called? This whole command is about time. So raise an exception and abort. If span is none, so span is initialized to none, and there's no span in the results, and there is a span in the results, so let's go use it. So span is basically, let's see if we can, span is basically telling, it's _span is a field that time chart outputs that is useful for our graphing libraries. And that allows me to know the range of each row. So you can just eyeball it and go, oh, that's an hour. Great. I wouldn't know that. So there's an _span field that lets me know that. And so I've got the span of each row, and I go and I get my current time. I say result on, I get the time field for the current row. I convert it to a float and then an int. So all this convolution is basically float it'll get you the subseconds, but we don't really care about the subseconds. Then we're doing spans ago. So if how many weeks ago was a particular event? Well, it's the maximum time minus it's the time of that event divided by how many seconds are in a span. So for example, if this was a few weeks, this is right now, max time is like right now, and this is an event from a few weeks ago. So now we've got the number of seconds from a few weeks ago divided by the number of seconds in a week. And that'll tell us how many spans ago we were. So it'd be like 2. Then we say, what should the new time of my event be? So I've got an event that's 2 weeks old. What should the time be? Well, it should be the old time plus moving me forward 1 or 2 spans, however many spans I was, times the number of seconds in that span. So this is just sort of taking events that are weeks ago and moving them into the current week in the exact right slot. If new time is not in time data. Okay, so this is for any given row, let's get rid of the add info just to simplify things. For any given row, there's a count or some other field from time chart. But when you're overlapping multiple series, Timewrap, 1 week, you're going to get multiple columns. So as we're running down these rows, we need a way to put multiple columns in. So we're not just running down this list once and done with it. We go through, and then if we see an event from the previous week, we have to put that column value onto the event from before. Let's take the case of the last hour and an hour a week ago. We're basically saying if there wasn't a field, if we haven't dealt with this time yet, let's go and create it. And now we're dealing with the data from a week ago, the same hour. Let's go and grab it. And then we're going to add attributes to it. So we're basically using a Python dictionary of a dictionary. And the dictionary is all the different column values. And the column values will get added as you have more wraps. The span start. What's the time that a span starts? Well, it's essentially the current time, max time, minus how many spans ago it was, times the number of seconds in a span, plus some hand waving in terms of the plus ones, because there's an issue of inclusion and exclusion, like do you include the last second of the week and so on. Finally, the series name. There's a little function I wrote called series name, and this uses the mode that we talked about with series equals short, right? So that will output S0, S1, and so on. So if the series name is short, then the column name is just S and how many spans ago. If it's exact, then we go and call another function that gets us a nice little time string. And if it's relative, then we do a little bit of math to basically figure things out. We get 4 weeks ago or latest 2 weeks. It's just a little bit of math that takes into account, makes a pretty name for a column. So latest 2 weeks. So if you said we're wrapping every 2 weeks and the series is relative, you see how we get latest 2 weeks, 2 weeks before, 4 weeks before, and so on. So where does this 2 come from? Well, that's right here. That's the scalar, and then the units. So all it is generating the nice name for the column. That's the series name. Then if the spans ago equals 0, then the latest is the series. So we're just basically making note of the latest one. Then for each attribute, so here's an interesting thing. So far we've looked at just time chart count, and there's a field called count. But time chart can also do this by, I want something that's numeric. Here, what is this? D. Great. Okay, so let's go back and split by D. So now I've got a column with different values of D, which is 0, 1, and null. So now, smarty pants, how do we do time wrap? What does it mean to wrap these values around? Previously we just said 1 week ago, 2 weeks ago, and 3 weeks ago. How do you do this? Let's see what it does. Well, let's first call it the correct thing. Wouldn't that help? Okay, so now you'll notice what we've done is we've just appended the series name, prepended the series name onto the wrap name. So we said value 1, latest week, value null, latest week, value 0, latest week. value 1 first week. So this one and this one are related. And if you visualize it, you'll get the mess you asked for, which is basically you can see multiple split buys over time. Yeah. So how do we handle that? Well, we have to figure out all the field names that are given by time chart. In this case, we have a field 0 and a field 1 and a field null. We have to go through, so for this result, this particular row, let's go through all the key values. That's just all the field values. And if it's not one of the ones that I'm ignoring, underscore time or all the info stuff, and if it's count, then you know what, let's just call, did you notice when we just had count, when the field name was count, it's just called count, and when we do time wrap, we don't say count underscore 1 week before, count underscore 2 week before. Basically, count gets a freebie. So the series name is just the attribute name is just the series name. But if it's any other field value other than count, we're going to prepend the name of the attribute. So as you saw before, we prepended things with null underscore 1 week ago, and so on. And then we basically add this to this row, which was the output. So we're basically just adding attributes to this row. Finally, interesting thing to know is these are all in order. It's not so easy. So you've got to actually get all your columns in order. So I just said take all the fields that we've seen. So let's go back up. Fields seen. So whenever I see a field, I just add it and how many spans ago it was. So a given field like 3 weeks. Let's use the by thing again. By d. So a field called null underscore 1 week before. How do I know to put it there? Well, I know when I created that field, I made a dictionary and I said field seen, name of that attribute, how many spans ago it was. So I know that this attribute was 1 week ago. I'm not like reparsing the text of this. So I know it was I know how many seconds ago it was. So I'm basically going to sort all the fields in time order from most recent to most distant. So now I've got my fields in order. Then I basically just pull out the values, pull out the field, make a dictionary of all the fields, and then finally I add the underscore time attribute to be the first one. So if I were to put them all in order, this underscore time wouldn't be the first one. And I want it to be because our Splunk's graphing library assumes that underscore time is the first field. Also, we need to add back the underscore span field. I'm sorry, not add it back, but we need to we need to put it back. Finally, we get our results from that dictionary we made, and then we sort them. So now that we've got all our rows that we generated, we sort them all we actually put them in earliest to latest, and then we call this SI function called output results. Normally a search command just calls output results with no other arguments. In this case though, I'm actually telling it. So here's the interesting thing. We're dealing with Python dictionaries. and they have no order, but you want to output the columns in a particular order. So how do you do that? Well, you pass in an argument called fields equals and the field order, and that allows you to specify the column orders. If you didn't specify this, your columns, which are currently represented as an array of dictionaries, would be a random order, or probably alphabetical order. So you wouldn't have underscore time in the proper place and so on. So if you care about the field order, then you'll need to include this. And that is it. You've output results. And then let's go back to main. We finish run, and we're done. That's it. And that is the search command. So in short, let me wrap this up. We do some argument checking. We see if we're being called to ask about our search command. Like, is Splunk calling our code to ask about our search command? If so, great. Let's tell it all about it. Oh yeah, and we want an operator to go first. Let's go and get our results. Let's go generate new results based on the input results. And then finally, we do some processing and we output the results. And that is how you make that search command. Let's go back. So now that we've covered that, we've actually covered every file in this little app. Once you're done and you have a directory called Timewrap, what do? Let's say you wanted to upload this to apps.splunk. There's lots of docs about this, but I have a little script that I run for any given app that you might find helpful, which is basically just go to the directory of the app, delete any Emacs edit files, any Mac files, any Python backup files or compiled files, then do a tar compressed of the Timewrap directory and put it in a file on my desktop called timewrap.spl. So a .spl is basically a tar.gz. So you're basically just, if you want to call whatever search commands you do to generate a tar.gz and then just rename it SPL, you're good. And then you can upload that to Splunkbase. And that's it. If you have any questions, you can email me at david@Splunk. I hope this was helpful. If you have any suggestions, please let me know. You can grab the app in the App Store, and if you have suggestions, if you have improvements, now that you know how to do it, make the improvements, send them to me, or make your own search commands and put them up there. All right.